There is a spinal condition that is usually defined as little fractures in the low back with a forward slip of one vertebra on another. It is called spondylolisthesis. Spondylo meaning vertebra and listhesis meaning slip. This definition barely scratches at the surface for this condition, as I discovered when I began to search through the literature on the topic. There are at least another 13 defining parameters for this condition. However, the problem is they are all descriptive only, and none are etiologic. That is, none can be crowned as the primary cause for this condition, including the defining fracture and slip. I am intrigued by the extensive study of this condition because I believe it is revealing some of the primary mechanisms of spinal function, such that eventually this knowledge may well spill over into the world of low back pain investigations and even redefine our understanding for this less well-defined spinal condition. This introductory video explores some of the recent additions and re-examined parameters for spondylolisthesis. I begin with the basic misnomer of one vertebra slides forward on another. Reviewing spondylolisthesis is a look at a spinal condition with many well-defined and measurable characteristics. Unlike regular low back pain, which is classified as non-specific because there are no specific determinable characteristics, the most frequently investigated spondylolisthesis, isthmic spondylolisthesis, now there's a mouthful, always has a structural defect present in the form of a fracture, and there is always a measurable gradable slip of the L5 vertebra on the sacrum. Indeed, 85% of spondylolisthesis defects occur at L5. As stated at the opening of this video, spondylolisthesis is typically defined as one vertebra slipping forward on another. This is in fact not an entirely accurate definition. Antoniades et al. In 2000 correctly pointed out that spondylolisthesis is not one vertebra slipping forward on another, but in fact it is the entire spine that slides forward on the sacrum. This is a significant shift in the classic definition and focus for this condition, that spondylolisthesis is being defined by local, adjacent and global parameters, rather than local pathology and local parameters only. This becomes very clear when observing radiographic images of spondylolisthesis, especially the more severe grades and the most advanced stage called spondylotosis, where the entire spine slips off the end of the sacral plate. Ouch! Vertebral slip, therefore, is not the only defining characteristic of spondylolisthesis. The normal L5S1 lordosis has long been known to descend into kyphosis for spondylolisthesis, such that as far back as Scaglietti 1976 and Boxall 1979, they considered spondylolisthesis to be a kyphotic deformity, and then Schwab in 1997 stated that spondylolisthesis is a kyphotic deformity with a translation of a vertebra. So not only is there a slip of L5 on S1, but also a rotation or flexion of the L5 vertebra on the sacrum. Spondylolisthesis is continually being re-examined and the definitions updated, and more recently authors have defined sagittal spinal parameters that are significantly altered in people with spondylolisthesis. Legay in 1998 defined and introduced pelvic incidence as a fundamental parameter in sagittal spinal alignment, and Debussy in 1997 redefined the measurement of Boxall's slip angle from 1979 as the lumbosacral angle, or LSA. LSA is a measurement for lumbosacral kyphosis, for which Viali 2007 stated that lumbosacral kyphosis is an even more predominant factor in theories of pathogenesis in spondylolisthesis than pelvic incidence. Lumbosacral kyphosis has been emphasized throughout the history of investigations in defining spondylolisthesis, but it is only recently that it is receiving a discerned and focused attention as a primary characteristic feature of spondylolisthesis. What is pelvic incidence, and what is lumbosacral kyphosis, and what determines them. It is these and other sagittal parameters that drive my interest in spondylolisthesis, because in fact these are some of the same parameters, especially the lumbosacral kyphosis, that I observe and describe for non-specific low back pain. I will examine these parameters fully in this video series. From observations of this more well-defined spinal condition, the knowledge base drives a new possible interpretation for this other very well non-defined spinal condition. And this is indeed where Rusulu and Pinheiro Franco 2011 pondered their dissatisfaction with the definition of non-specific for two major spinal conditions of low back pain and degenerative disc disease. And they called for an exacting biomechanical analysis of these conditions. Measuring lumbar lordosis for low back pain has an all too variable outcome. What has become apparent is the need for determining segmental vertebral lordosis rather than total lordosis alone, because as we shall see, L5S1 can have a decreased lordosis and even be kyphotic, while simultaneously L1 to L5 has an increased lordosis, perhaps in fact as compensation for the kyphosis. And all of this is missed with a total lordosis measurement only, and leads some researchers to conclude that lumbar lordosis is a weak characteristic in the definition of low back pain. Whereas for spondylolisthesis, authors like Labelle and Viale, lumbar lordosis is credited as fundamental and critical in spinal alignment, and this becomes more clear the broader the investigation, which is why I am making this presentation, to broaden the view. And it matters how you measure lordosis. I will review some of the procedures and the difficulties in radiographic measurement for spondylolisthesis. Investigations of sagittal parameters in these spinal conditions, I believe, set the scene for how we should be examining non-specific low back pain. And I believe there will be good answers in this exploration. Spondylolisthesis and its necessary precursor, spondylolysis, presents asymptomatically in 6-year-olds at a prevalence of 4%. That is, spondylolisthesis is a childhood condition. The prevalence of spondylolisthesis climbs to 6% by adulthood. And it again presents this time symptomatically in adolescents, especially athletes, and indeed in certain sports. Adults over 50 can develop another form of spondylolisthesis, the degenerative non-fracture type. What causes spondylolisthesis, and why and how does it progress? Are there genetic factors, or are they mechanical or environmental, or all of the above? Spondylolisthesis has only once been reported in a newborn and only once for a non-ambulatory human, that is, someone who is bedridden or chair-bound. What is it about turning 6? Is it going to school, or is it leaving home? Is it sitting in chairs, or is it rough play? Inevitably, all discussions on the origin of low back pain in humans leads to a review of our standing on two legs. When considering our upright stance, medical anthropologists like Abitbol 1997 make profound statements like, "Our bipedal achievement is only skin deep and is easily subject to imperfections, misadaptions, and regression." And further he states, "In conclusion, erect posture is not only a phylogenetic inheritance, but also ontogenetic." Meaning that even though we are destined to stand on two legs because of our phylogeny, that is, the genetics of our species, it is also a matter of mastering the task in our lifetime, that is, our ontogeny, what we learn in our lifetime. The ability to stand and walk on the Earth's gravitational field not only has genetic origins, but also learnt origins. This, in fact, may well turn out to be the major issue for low back pain. That is, how we stand in the world. I will review the recent sagittal spinal alignment assessment being investigated for all spinal conditions. In this video series, I will fully examine the story of spondylolisthesis as much as it is known today. I have to compliment the many authors in this story for their great work in following the story and seeking a truth, not just in the understanding of this spinal condition, but also for the implications in our understanding of the human spine in function and dysfunction, and especially for our future understanding and management of low back pain. Thank you for watching. See you in the next episode.